Hello everyone, welcome back to our channel. Let's discuss the next name reaction, that is Chapman rearrangement. This is an example of rearrangement reaction. Let's see the statement. Thermal aryl rearrangement of O-aryl iminoethers to amides. Iminoethers to amides. So here the reactants are O-aryl iminoethers. This is not the ortho position. This one is O-aryl. It means the aryl group connected to oxygen. Okay. Next, imino group should be there. And ethers. Ether means which linkage must be there? Oxygen carbon linkage must be present. If you see the reactant, here it is a oxygen, right? O-aryl, oxygen is connected to aromatic ring, aryl ring. Okay. The next one is what? Imino. See this one. C double bond N is the imine group or not? The imine group connected to oxygen. That's why this is O-aryl iminoether. This is subjected to the thermal conditions to produce the corresponding amides. The products are amides. So simply how can we understand? See this. Whatever this carbon oxygen is present in the reactant, this can be converted into C double bond O. Simply this double bond is subjected to breaking. The double bond will be converted into single bond. Simply we can say the shifting of this aromatic ring from oxygen to nitrogen. Simply the phenyl ring is connected to nitrogen, thereby these pi bonding electrons to form a pi bonding with the oxygen. That's why we are come up with, see this ARN, ARN, the phenyl group is shifted to nitrogen, C double bond OR. Simply you need to remember in that way. If you see the mechanism, see this, in this reactant the nitrogen containing lone pair of electron or not? This lone pair of electron is subjected to involving in the formation of a four-membered cyclic ring. Here what is happening, see this one, the nitrogen electrons donated to the ring carbon. Thereby what happens? The nitrogen carbon single bond will be formed. The nitrogen will take positive charge. Okay. So here the carbon is forming a bond with nitrogen. It means at this carbon the valency is increasing or not? That's why what happens? These pi bonding electrons moving towards this carbon. That's why this carbon will take the negative charge. Now this is involving in the delocalization with this pi bond to form negative charge here. Again this is involving in the delocalization with this pi bond again to form negative charge here. It means the electron density is continuously in delocalization or not. That's why what we are representing, see this. This is minus. The negative charge is distributing among the carbon atoms. Okay. This intermediate is called oxygenate intermediate. Now this is involving in the decomposition. See this. The single bond is forming the pi bond between the carbon and oxygen. So we are coming up with C double bond O. In order to neutralize this one, these pi bonding electrons move towards nitrogen. Okay. Here see, already minus charge is there. By breaking this bond, we are giving the positive charge or not? That's why the negative and positive forming a pi bond. In this way, the oxygen connected aryl group, remember that this is not ortho position. Okay. Aryl group connected to oxygen in the iminoethers converted into amides. That's why the shifting of phenyl ring takes place or not? This is aryl group or not? We are saying thermal aryl rearrangement. Okay, so let's see the examples. Sometimes what happens, we may not get the product. Oxygen connected aryl amino ether. Here if you observe this particular application, here see sodium from this atom and Cl from this one removed in the form of NaCl to develop a ether linkage. See this ether linkage. This is the oxygen. Right side aromatic ring is there. Here see oxygen, right side aromatic ring is there, left side C double bond N should be present, right? Here similar situation. Oxygen, right side aromatic ring is there, left side C double bond N is present. That's why this one involving in CR rearrangement. Okay, to produce the corresponding amide, what happens? The C oxygen single bond can be converted into double bond. The complete R group shifted to nitrogen. The complete R group shifted to nitrogen and C double bond. Again, this is subjected to hydrolysis to produces further product. Okay. See the next example. Same. Oxygen right side aromatic ring, left side C double bond. So involving in the CR rearrangement, simply this single bond converted into double bond, this aromatic ring shifted to nitrogen. Okay, Chapman like rearrangement, this is something important. So in Chapman rearrangement we are observing to the right side of the oxygen we should have aromatic ring. Here what we are observing, to the right side we are observing some aliphatic moiety. This may be a ethyl methyl like that. Okay, so this aromatic ring is replaced with R group simply. That's why the people are saying Chapman like thermal rearrangement. Here what happens, the R group will be shifted to nitrogen, there is double bond converted into single bond, and this single bond converted into double bond. Simply we will come up with C double bond O, C double bond O, R shifted to nitrogen. In this way we can write the products. Okay, so this is Chapman rearrangement. Thank you.